This tutorial is about creating the elements of a full ecosystem for the development of programming for application programming interfaces. We want developers to create client apps to access API services. But first, developers need to find or discover that the API exists, perhaps from a gallery of available APIs, particularly a gallery which has done quality scans of the machine-readable API interface specs. Documentation about the API helps not only for the API to be discovered from the public galleries, but also for developers to more quickly appreciate the intricacies of that API. What's even better than reading documentation is to interact live with a sample demonstration app so developers and potential users can really grasp the value of the services exposed. It helps to have enough sample data so sample test automation scripts have the test coverage needed to give assurance that all features really work and work quickly, even under load. Many developers now also like having a mock server running locally so they can work anywhere with a stable endpoint, even while off the network. Many have found this shortens development cycles by reducing the need to wait for others to achieve stability in dependent modules. All this is what makes up a full API offering. It takes effort to create docs, demo, test, and mock server code. That is why many have begun writing automated generation of such code. But ideally, the logic used to generate this code would be based on both the interface specifications and wisdom culled from analysis of the metadata gleaned from the pattern of growth in data over time. More sophisticated variation of data values in generated code is now the frontier. Such data include values and statistics from both historical points in time and projections, plus predictions of values expected in the future. With apps of enterprise scope and complexity, manual coding of the client and server codebase by human developers can seem repetitive and be error-prone, therefore taking more time and be more expensive than what could be. So instead of manually defining interface specs, we can generate those specs from the codebase by marking up the server code with comments recognizable by a parser such as Deoxygen. There are other extraction programs for each of several competing API specification formats such as RAML, Waddle, and Swagger, but Swagger seems to be the most popular at this time. Programs are getting more mature at reading specs to generate programming code in various programming languages. Being able to generate a demo app from specs would cut time to market and encourage reusability of code. To ensure quality in generated code, community agreement of a strong set of rules used to drive quality scans of specifications can not only boost confidence, but also provide a differentiator for community collaboration.